Hi guys, so in this video we're going to take a look at solving exponential equations. We're going to solve these equations today by manipulating the equation to have the same base on both sides and then equating the indices. Basically what this method relies on is if we've got, say, 2 to the power of f of x equals 2 to the power of g of x, then we can simply state that f of x must equal g of x. If we've got the same base to a power and it equals that same base to another power, the two powers actually have to be the same, otherwise you would have different numbers. So we can do away with the base altogether and just equate the indices. We'll take a look now at a couple of examples to see how this works. So here we've got the equation 3 to the power of x plus 2 equals 243, and we need to solve for the value of x that makes that statement true. And what we do is we realize that 243 is simply 3 to the power of 5. So we can rewrite this equation as 3 to the power of x plus 2 equals 3 to the power of 5. Now, as we were saying before, if we've got the same base to a power and it equals that base to another power, those two powers in fact have to be equal. So what we know is that the only way this is true is if x plus 2 equals 5. And in that way we have 3 to the power of 5 equals 3 to the power of 5. For that to be true, we just solve it as we would any other equation, and in this case x plus 2 equals 5 means we've got x equals 3. The next equation we'll solve is 4 to the power of x plus 1 plus 8 equals 12 times 2 to the power of x. And what we're going to do is we're going to separate this first term into 4 times 4 to the power of x plus 8 equals 12 to the power of 12 times 2 to the power of x. And then we're going to write this as 4 lots of 2 to the power of x all to the power of 2, because that gives us 2 to the power of 2x, which is the same as 4 to the power of x, plus 8 equals 12 times 2 to the power of x. Now you may not immediately realize this, but we've actually got a quadratic here, and it's easiest to see if we make a substitution. So we'll say let y equal 2 to the power of x, and then we can immediately see that we've got 4y squared plus 8 equals 12 lots of y. Dividing through by 4 and rearranging, we get y squared minus 3y plus 2 equals 0. And we can solve this as y minus 2, y minus 1 equals 0, because negative 2 and negative 1 multiply to give 2, and negative 2 and negative 1 add to give negative 3. And this gives us our solutions, y equals either 2 or 1. Putting that back into our substitution, we know that y is 2 to the power of x. So if 2 to the power of x equals 2, that would mean x equals 1, because of course that's to the power of 1. If we have 2 to the power of x equals 1, then we have x equals 0, because 2 to the power of 0 is 1.